These are the notes for Chapter 7, Unit 4, for similarities within right triangles. What you'll need is a rectangle that has some triangles already drawn on that to start the activity. First step of the activity says draw the diagonal. The diagonal of the rectangle is already drawn for you on this sheet. So we're going to go ahead and cut that. Step number 2 was to cut this out and to make two triangles that are going to be congruent to each other. When we cut this rectangle in half, we have two triangles that are congruent to each other. On one of the triangles, it has an altitude already drawn on it. We're going to go ahead and cut along that altitude. That's step 4 on this activity. An altitude forms a right angle here with the base, and now we end up with three triangles. First one being the large one, we're going to label it as shown, this being the right angle, and we'll label this as angle 2, this one is angle 3, or excuse me, as angle 1, and this one is angle 3. That's from the large triangle. Two other triangles, we're going to label the medium-sized one, with this being the right angle, as angle 5, this as 4, this as 6, and finally the small one, we'll see as it's shown here, this one is the right angle, we'll label that as 7, this angle 8, this angle 9. Step 6 says compare the angles of the three triangles by placing the angles on top of one another. So we'll start here with the large one, and if I take the small triangle and lay it on top of it, obviously we have a right angle here. These two angles are going to be the same, but I'm trying to match angle 1. Not quite with angle 8, or angle 9, but you'll see that when I lay this on top, that angle 8 and angle 1 are the exact same size. With the small triangle, and right angle here, that's not going to be equal to angle 1. Angle 4, a little bit too big, but when I lay the medium triangle on top, you'll see that angle 6 and angle 1 are the exact same size. So we've found that angle 1 is congruent, or has the same measure as angle 6 from the small one and angle 8 from the medium-sized one. Let's do the same thing for angle 2, which is pretty simple because we already checked that when we did at the beginning. You'll see that we had right angles here at angle 5, angle 7, and angle 2 are all right angles, and therefore they're all going to be the same size or congruent to each other. So from the small triangle, we had angle 7, and from the medium-sized triangle, we had angle 5. We have one more angle to check, and that's angle 3 from the large one. I think most of you probably already see that if we take the small triangle, 8 and 1 lined up, and 7 and 2 were the same size. And now if I put this angle 9 directly on top of the large triangle, we'll see that angle 9 and angle 3 are congruent to each other, or the same size. And same thing here. We had 5 and 2 from the medium-sized one, 1 and 6 from the medium-sized one, and now if I lay this directly on top, you'll see that angle 4 and angle 3 are the exact same size. So, again, to answer this, we know that angle 9 from the small one and angle 4 from the medium one were the exact same size as 3. Based upon this, we know that what's true about all three of these triangles is that they are similar to each other. They are similar by, all we needed were two of those angles, or angle-angle similarity postulate, which goes to show here the big idea of today's lesson, and that is when we have an altitude drawn, and that's what was drawn here. You can see in this triangle an altitude, Bn, to the hypotenuse of a right triangle. We started out with a right triangle. This only works and applies to right triangles. It divides the triangle into two triangles that are similar to the original triangle. And even these two are similar to each other. Big thing we want to do with these is when we draw this altitude, we want to be able to redraw all of the triangles that are associated with this. Each time we do this, we're going to get a large triangle, a small triangle, and a medium-sized triangle. Okay? So first of all, let's just redraw and label the large one. Real simple. This is A. Our right angle is here at B, and then we have C. The other two triangles, A and B, is going to be the medium-sized one. B and C is going to be the small triangle. This one's the large one, or the big triangle, the one we started out with. So large, medium, and small. The medium-sized one is going to look like this. Angle N is the right angle. Angle A is over here, and then now that is vertex B, angle B in the medium-sized one. And this one is the medium-sized triangle. And then we'll draw the small triangle with the right angle here at N. This is vertex C, and this is vertex B. There's the small one. That allows us to write some proportions between these. In this, you'll see that AB is to BN. AB is this side here. AB is opposite of angle C. AB is this side here, and it is, I think I may have, I'll let you guys catch up a little bit. I think I was off the screen when I was doing this, so I apologize. But let me state what I did here. Our medium triangle is here. It's made up of A, B, and N, N being the right angle. The small triangle is this one right here. B, C, and N, N being the right angle. And now we're using these to write our proportions. AB is to BN as, and this is from the large triangle to BN in the small triangle. It's opposite of this angle here. C and C are the exact same size. So AB is to BN as, you'll see the hypotenuse in the small one is BC, and the hypotenuse in the large one is AC. So to solve this proportion, X is going to be AC. This one was comparing the large triangle to the small triangle. Let's try our next one. A little bit of practice on these is going to help you get this down. So let's take a look here. We have AC, which was again our hypotenuse from the large triangle, is to AB, which is the hypotenuse of the small triangle. or excuse me, I'm sorry, the medium-sized triangle, hypotenuse to hypotenuse, as BC. You'll see that BC is opposite of angle A. BC from the large one. Okay. We're comparing here the large triangle to the medium-sized triangle. So we're looking for, on the medium-sized triangle, the side that's opposite of A, which in this case is BN. BN is opposite of A. So therefore, X in this case is BN. Let's try another one. The next one, we're comparing BC to NC. BC to NC. BC was in the large one. NC, you'll see, is in the small one. So we're comparing large to small. BC is opposite of angle A. That's this one. And then NC is opposite of this angle here, which is going to be the same size as angle A. See, these two angles here are the same. Of course, the right angles are the same. So angle B in the small one is going to be the same size as A in the large one. Therefore, the side opposite that, NC, will have the same proportion as, let's look at BN. BN is the side opposite of angle C. So we're going to look in the large one, the side opposite of angle C is AB. So X in this case is AB. Let's do one more. And in this one, we're comparing AN and BN. You'll see AN is not in the large one, but AN is in the medium-sized one. AN is this side here, which is opposite of that angle here, that's at B. So we're comparing AN in the medium-sized one to BN in the small one. BN is opposite of this angle here, which is congruent to angle B. Let's see that these two angles are the same, the right angles are the same, and angles C and B are the same. AB from the medium-sized one is our hypotenuse, so X is going to be the hypotenuse from the small one. Again, comparing the medium to the small, with this side being the hypotenuse, so X is going to be the hypotenuse from the small triangle, which in this case will be BC. And that's what X is there. Let's try this again on another example. This may help you a little bit more. First few times doing these, it does take a little bit to get used to, but the key here is always redraw this. This is very confusing as it's shown. So redraw your large triangle, and this time it may go a little bit easier for you because we don't label this by the vertices, we're just going to label the sides by their lengths. This side would be a length of B, this side a length of A, and this side a length of C. And then I'm going to highlight this to help you see the relationship between these. C is our hypotenuse. It's directly opposite of our right angle. And then this angle here appears to be the smallest one, so I'm going to highlight that one as the small angle, and A is the side that's opposite of that. And then you'll see that B is this third side, and it's opposite of this angle down here, which is the medium-sized angle. So there's our large triangle. Large, and now let's draw the medium-sized triangle. I'm not going to spin this around. I'm going to draw it exactly the way I see it here. Okay? Exactly the way I see it. with a right angle here, and this length being x, this length being h, this length being b. And again, I'll highlight this to help us see the relationship between each one of these. Opposite the right angle is side B. That's our hypotenuse. Then the small angle in here is this one. The side opposite of that is H. And then finally, this last side, this angle, X is opposite of that angle. With these two angles being the same size, this angle up here, this part of the right angle, is going to be the same size as that one. So that's why I've highlighted all those in blue. This is our medium-sized triangle. And then finally we'll draw our small triangle. This one is our small one. The lengths here are Y, H, and A. In the small triangle, A now is the hypotenuse. It's directly across from the right angle. And now the small angle in here is actually this one up here. This is the small angle. I'm going to highlight that. It's very important that we get all of the corresponding angles lined up with each other or identified with each other. The side opposite of that is Y. And then this angle here is the same as that one. That's the medium-sized angle. It's not the right angle. It's not the smallest one. And opposite of that is H. The color coding is going to help us with lining these up. And again, this one probably will go a little bit easier than last time because all we're doing is talking about just the lengths of the sides, not AB or BC like we did up above. So let's try this one together here. First of all, you can see they say X is to H. Well, X is in the medium-sized triangle. So this one's comparing the medium size to H in the small one. So we're comparing the medium-sized triangle to the small triangle. And you'll see that the way I've highlighted these, X and H are both blue. So I'm looking for, in the small one, Y, which is opposite the smallest angle, which I've highlighted in the pinkish color here. Y is opposite of this angle, and that's my denominator. So I'm looking at medium is the triangle that I'm looking for in the proportion over here. In the medium triangle, the side that's opposite the small angle is H. So our value here would be H that we're looking for. X is to H as H is to Y. X is to H as H is to Y is our proportion. The next one, it's comparing A and B. A and B. You'll see in this case, A is in these two, and B is in these two. But when we compare them, we want to line them up so that they're comparing the same thing. So if you'll notice, A is the hypotenuse in the small triangle, B is the hypotenuse in the medium triangle. So that's the comparison we're doing this time. We're comparing the small triangle to the medium triangle. A, the hypotenuse in the small, to B, the hypotenuse in the medium triangle. Let's finish this proportion. So you'll see in the medium triangle, our denominator, we're looking at side H. H corresponds to side Y. And mine you can see because it's highlighted, but if you didn't highlight it, notice H is opposite of the smallest angle. Y is opposite of the smallest angle. So Y is our value here that we're looking for. Let's go on to our next one. In this one, we're comparing A to C. A is in the small one, C is in the large one. So instead of the hypotenuse and the small to medium like we just did, this time we're comparing the small one to the large one. Small to large, both of these are the hypotenuse. And now y is in the small one, small triangle, opposite the smallest angle. So we're going to look for the large triangle, and in the large triangle, the angle opposite the smallest angle, the side opposite the smallest angle is side A. So in this case, our value is A. A is to C, hypotenuse is to hypotenuse from the small to the large, as Y is to A. The smallest side is to the smallest side from the small triangle to the large triangle. Let's try one more here. In this one, we're comparing B to X. B to X. B, you'll see, is in the large triangle. It's the side opposite of this medium angle. X is the side in the medium-sized triangle that's opposite of this angle. So B is to X would be a large to medium, as something is to B. B, you'll see, is in the denominator, so it's from the medium triangle. And in the medium triangle, B is our hypotenuse, so the value we're looking for is the hypotenuse from the large one, which would be C. Okay? So this first process might be a little bit difficult for you to see right now, but as we add numbers to it in our problems, this will go a little bit smoother when we do that. So let's turn to the next page and continue on. And on the next page, you'll see that the guide is drawn for us up here. And this is what you'll need to do every single time you have problems like these. Redraw the large triangle, the medium triangle, and the small triangle. And in those, the key is, as I've highlighted on the previous ones, we want to match up the hypotenuse from the large one always to the hypotenuse from the medium one, or the hypotenuse from the small one. Or we want to line up the smallest side. What I'm going to ask you to do when you draw these is go ahead and shade in the smallest angle in each one of these triangles. Smallest angle is this one right here. So when I redraw the large one, it's going to be that angle. In the medium one, it's going to be this one. The side opposite that is this one. And that in the small one, it's a little bit difficult sometimes for you to see the first time through, but it's the one that's up here. It's this angle. Okay? These are the smallest angles in all of those. The side opposite that is this. So whenever we write our proportions, we'll compare A to H, or A to M, or H to M, the smallest side from each one of those. And then I'll highlight the last side for you, and this is the medium-sized side. Okay? It's opposite of the other angle here. So B and N, B and H in this example. Okay? So let's take the first one nice and slowly. First step always is to redraw the triangles. So very first problem, we're going to redraw this, and I'm going to be careful to put it exactly the way I see it. This being the right angle, and then I'll redraw the medium-sized one like this, this being the right angle. And there's my medium-sized one. And then I'll draw the small size one, like this. Oh. Okay, there's my small one. Okay? Now, again, what we did on the previous one was just lining up and writing some proportions. You're going to probably find this a little bit simpler because we don't have to kind of guess at what our proportions are. What we're going to do is, first step, redraw the triangles, and then label the three triangles with the dimensions that are given to us. So you'll see in the small one, this length here is 2. This length here is 3. Do I know what that is over here? No. I'm not even going to write anything down for it. Don't put an X or anything at all on there. Keep it blank. In the medium-sized one, you'll see that we do know that this length is X. This length is 3. Similar to what we did in the small one, that length there is not known. We're not going to write anything for it. When we look at the large one in this one, guess what? We don't know what this side is. We don't know what this side is. As a matter of fact, this one is something kind of weird. It's going to be an X to here and 2 to there, so this is an X plus 2. Don't get too scared with that, because here's the nice thing about all of these problems. When we draw the altitude in a right triangle and get these similar triangles, yes, we'll have 3 triangles, but to solve one of these variables, we only need 2 triangles. And hopefully what you can see here is this large one doesn't give us enough information. We're not even going to use this at all to solve our problem. What we're going to do is use these 2. So first step, redraw your triangles. Second step, label them with what you know. And then before you write your proportion, look closely. You're always going to eliminate one. You're only going to use one of these triangles. Okay? So now, in our triangles, you'll see that this angle here is the smallest one, which happens to be this one in the medium one. Exact same thing. And then in the small triangle, it's this angle that's corresponding and congruent to that one. So I'm going to shade that in. Remember, that was the key that I wanted you to do in each one of these, is to shade those angles in so that you can know what is going to be corresponding in your sides. So here's what we're going to do. We're going to compare the medium one to the small one, medium triangle to the small triangle. The side that's opposite of this angle is 3. 3 is to 2. Notice 2 is opposite the same size angle. 3 is to 2 as x is to 3. You'll see x is opposite of this angle, and 3 is opposite of the same size angle on the other one. X is to 3. Now, before you solve this, stop and look, because believe it or not, every time we write these proportions, we get a message from God telling us that, hey, this is right or this is wrong. And here's the thing. Every time we get these, we should always see in one of our cross products the exact same thing. And that's the message or little hint that says, hey, I've got this right. If I have 3 times 3, or an x times x, or a 2 times 2, then I know that I've written my proportion right, and now I can solve this. And the nice thing about this one is, this one's just a simple, same thing you did long time ago and done for many years. It's just a cross multiply and divide. 3 times 3 gives us 9. Divided by 2 tells us that x equals 9 divided by 2, or 4.5. And we're done. Let's try the next one. Step number 1, redraw our triangles. Start with the large one. Right angle here. And then our medium-sized triangle. Drawn right here. Right angle. And then the small triangle, drawn like this, right angle and small. On this, I'm going to label this one as the smallest angle, smallest angle, smallest angle. And remember, in the small one, it's going to end up being this one up here. Labeling it with the dimensions that we know. Let's take a look at this x here and 8. That's our small triangle. This is x, and this is 8. In the medium-sized triangle, this is x, and this is 18. In the large triangle, this side here, hypotenuse is 18 plus 8, or 26. Okay? So first step, redraw your triangles, labeling the smallest angle in each one of those, and putting all your dimensions on it. And before you write your proportion, look and you'll see that just like we did the last time, the large one is not going to be used. Now that's not always going to be the case, but remember, we're just going to use 2. This time, like we did last time, we're just going to use the medium and the small one. And I'm going to stop right here and we'll continue on later.